Hi folks, welcome to Advent of Code in F#, day 1. New year, I'm really excited to start, so I'm going to dive right in. Let's see what Advent of Code has in store for us today. Trebuchet, cool. Something is wrong with global snow production, and you've been selected to take a look. The elves have given you a map on it. They've used stars to mark the top 50 locations that are likely to be having problems. You've been doing this long enough to know that to restore snow operations you need to check all 50 stars, of course. Collect stars by solving puzzles. 2 puzzles will be made. Yes, same thing. Good luck. You try to ask why they cannot just use a weather machine, not powerful enough. And where they're sending you the sky and why your map looks mostly blank. You sure ask a lot of questions. It sounds like an IT project. And hang on, did you just say the sky, of course? Where do you think snow comes from? When you realize that the elves are already loading you into a trebuchet, please hold still, we need to strap you in. That's a catapult, right? Trebuchet? Yeah, one of those big ones. Cool. As they are making the final adjustments, they discovered that their calibration document, which is our puzzle input, has been amended by a very young elf who was apparently just excited to show off their art skills. So elves are having trouble reading the values on the documents. The newly improved calibration document consists of lines of text. Each line originally contained a specific calibration value that the elves now need to recover. On each line, the calibration value can be found by combining the first digit and the last digit in that order to form a single 2-digit number. So we need to find the first and last digit in a line and combining them, which means string concatenating them. And then we just sum it all up. Okay, that's a nice warm-up. That's a nice day 1 for this year. Let's take the example input and let's get started. As always, we're using F#. So let's give it a try here. These are our example input lines, and let's go ahead. So we need to treat every line and extract something out of it. That sounds like a job for a map function. So let's map over the example. And for every line, we need to parse out the, what was it called? The calibration value. So let's write a function for that, and let's define that function. And how would that work? We need numbers, and we need the first and the last number. So let's first take the numbers. We can do that by just iterating over the line or filtering the line even, like going over every character, and if it's a digit, we can keep it, otherwise we can skip it. So let's define line, let's give it a type so we can iterate over it. Does it matter? Sequence of cars, let's make it a string. It's literally a string, right? So then we can do line, and we can filter, and we can provide a filter function. And the filter function can be, it's a character, it's a digit, sorry. So we only have the digits now, and we need the first and the last one. And then we can string concatenate them. Or a digit is always between 0 and... No, let's not do anything fancy. So these are 2 characters. Let's string concatenate them by using a... sprintf. Why not? Let's use a format string. And let's concatenate first and last. And let's parse that into a number. I'm gonna give this a name, and then we can just return the combined thing parsed to an integer. There we go. I don't know why my compiler or my type checker is slow. I see squiggly lines while my code should be compiling. So there was a lot of typing and not a lot of checking, so let's check. I see 1238, 15 and 77. That is correct. And then we just need to sum the whole thing. It's 142, so that should work for us, right? I'm gonna wrap this in a function and I'm gonna call it on the example just to make sure everything still works, but it should. There we go. And now we can provide our input. Let's quickly grab our input. Get your puzzle input here. A 1,000 lines. So input should also work if we use input. Let's see that we read our input from disk. There we go. Sorry. Let's see whether or not we can parse it. No, that's interesting. It's an empty list. Oh. I used to call my files input.txt, or so it seems. There we go. We have a biggish number. I'm pretty confident that this will be correct. Let's check it out. Hey, 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 we got our first star. Nice warm-up. Let's see what part 2 has in store for us, right? Our calculation is not quite right. It looks like some of the digits are actually spelled out with letters. That is interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, I like this twist. I think it's a bit hard for day one, no? Nah, it's doable. Okay, interesting twist. So we need to find the real first and last digit on each line, which is 2 and 9 here. Okay, I see what's going on. Ooh, is this a different example even? Yeah. Okay. Cool twist. Let's make a part 2. I never bother changing code for part 2. It's just a one-off script. I just copy paste my code and wreak havoc on whatever I have here so I can get part 2 to solve. Okay, so something changes, which is when we are looking for the digits here, we are doing this by looping over every character and checking whether or not it's a digit. That won't work anymore. We need to loop over every digit being 0 to 9 in digit form and 0 to 9 in text form. So I'm just going to make a I think a lookup table that maps every digit or every form of every digit to the correct digits, and just like see whether the string starts with it or not, and otherwise we're just gonna parse to the next digit. That's how I'm gonna try it out. That's a lot of waffling, so how would that look like? I need a lookup table. And lookup table in F# you can use a map. It's a dictionary kind of thing. It's immutable. It's thread safe. It's immutable because it's thread safe, or other way around. But that's not really relevant. It's a lookup table. And you can make it from a list if you provide tuples providing a key and a value. For example, if I have a 1 in my string, that should resolve to a 1, right? So this is, I hope, correct. I don't know why my squigglies stay that long. I'll have to look into that for tomorrow. This is .NET 8. So maybe the new .NET thing and F# or the new Visual Studio updates and the new F# updates are not good friends. That also always happens. F# is like the least favorite kid around the Visual Studio block. But anyway, I digress. Let's continue on this lookup table, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just build this thing and map the digits to their values. It's not strictly very interesting for 0 to 9 as we have here, but I think this will become interesting for the text versions, which is why I'm doing this. Because 0 also maps to... Is 0 even? Yeah, I think 0 should be there, right? Let's see if it's in there. 0 is not in there, so we shouldn't even be bothering. Okay. No, 0 is not in there, so I'm not gonna put it in there either. Bit of boring stuff to get the fingers working. And I think I'm thinking ahead already. I think now we can just write a recursive parser that nibbles up every character of the line, or nibbles up every digit we find, and if we don't find anything, we just treat the one digit we just saw, or the first digit we just saw, as irrelevant. So what's going to be a bit more difficult, it's finding the digits. So I'm gonna extract it into a function. And I'm gonna start tweaking that part. So this is what we extracted. I don't know if my refactor shortcuts work actually. No. Resharper refactoring shortcuts do not work for F# scripts. So, okay. I extracted it into a function and now we can start tweaking it. The tweak is going to be going over a line and seeing whether we have one of these things at the beginning. So, if the string starts with one of these things, we have hit a digit. And then we need to continue with the rest of the string and do the same until it's empty. So it sounds like a recursion problem for me. So let's do that. And do we need to have tail recursion? Let's refactor to tail recursion in a second. So day one is a bit interesting. But if line is empty, let's do it with, let's pattern match. Yeah, let's pattern match. So I'm gonna make the string a list, and now we can pattern match using list syntax. It's two lists. So now we can pattern match on the empty list, and then we know we have no more digits. You know what I'm going to do? No. Stick with the plan, yo. Stick with the plan. So I'm saying if my line is empty, we're done. We have no more digits, and otherwise we have a line which contains digits, but we don't need to match on like the first digit. We need to match on whatever. We need to match on whether or not the line starts with one of these things in lookup. So that's what we're doing here. So match on line when this line when lookup when that contains when for any one of these values the string the line starts with it. So sec exists, I think, is what you can use. So L dot starts with, and then it would be handier to have a string. Yeah, let's do string. So if it's the empty string, and otherwise link starts with, let's give it a type. So we can help the compiler here. I need the with keywords. Oh, my F# is rusty. I have not programmed in F# for a while. But there we go. So now we can do line starts with the digit. And we can, because it's the last argument, we can get creative and make our code very unreadable. There we go. I was getting confused, but now I see what's wrong. We're not returning anything. Our pattern match is incomplete here. So, this case, when we have a value in our lookup table that the string starts with, we have a hit. So we can just process the hit. So we can return. We can return that lookup. Can we do that in one statement? So this is filtering, but I also want to, it's like this is a Boolean, but I need to have the value. Can I do that? No, that's matching and returning. I'm making this too difficult. Let's just, it's not ideal, but my brain is in early morning mode. It's 6 o'clock in the morning here. So I'm just gonna do the thing again, which is not really ideal, but okay. And then we return the digit and the recursive. And for the tail end, we need everything except what we just consumed. So except what we just parsed with this starts with. Okay. Let's use a substring function here, and it should, oh dear lord, indexing. How many characters should we get rid of? What should be the new start index? If our digit took 1, 2, 3, 4, it should proceed to 0, 1, 2, 3, 4. So it should be the digit length, I think. Digit is why is digit an int? Look up map strings to int. Map values should give me strings. Yes. Let's get rid of these squigglies. I'm confusing myself very much here. There we go, that should work. Why is this not working? What is L here? A string. L should have a starts with. What is D here? Why is D an integer? Oh, values is not what we want. Oh dear lord, it's keys. Oh dearie me. I don't think we have leveraged the full power of our map here. But okay. We have the digit, yes. We have very much not leveraged the... Oh, but we are going to. Yeah. So we have the digit here, which is a string. We have a rest here, which is substring without the digit we just parsed. And now we can recursively call this thing on the rest of the line. This expression, okay. This compiler thing. This is not really correct because digit is a string and we need integers, and we can do that by parsing it or by looking it up. So look up, this is where we actually use our map. Get item find, what's the, how do you look up something in a map? Okay, find, I guess. Nah, there has to be a give me the value in map. Oh, it is this thing. So map.find takes a key and returns and map, of course, and it returns a value. So lookup digit. What I'm not happy about, I already discussed, so we're gonna fix that later, but this should work in theory. And this we still need to do on line 49 if we have no match, so it is a non-empty string, but we have no digits at the start. We just need to eat up or parse one character and try again with the rest. So that's what we're going to do here. So we're just going to recursively call find digits in the rest of the strings, skipping one. And because it's method calls in C# things, we need to put some parentheses around. Cool. So let's take a quick look at that, what our find digits function and what the signature looks like. It takes a line which is a string and it returns an int list. That is exactly what I expect. So it takes a string, so we don't need to do two lists here. And I think this should compile. It is compiling. First and last are integers, so we don't need to combine anymore. That is true. So we just need to... Oh, we do need to combine. But they are not characters anymore. That's what's wrong here. Is I the shorthand? No, D is the shorthand for a digit. Yeah, I think so. And everything stayed the same. So let's try solving the example. We wrote 0 tests. We just did a lot of noodling around. It should be 281. It gives me 281, so I am confident enough. So let's run this on our inputs. It is a biggish number. That is always a good sign for advent of code. So let's check it out. Ooh, painful. Not the right answer. Okay, let's take a step back. Breathe in, breathe out, and let's take a look at what we actually were doing here. So, quick reread of the part 2 thing, spelled out with letters. Why does it work, for example, and not for input? My thought process here, maybe I have a typo in one of the digits. Does not look like it. Maybe I have a typo in the mappings. Does not look like it. Okay, so maybe the bug is in here. Let's start writing some tests, right? For find digits. Oh, I already know what's... Is it? I'm thinking maybe the order in which I return the found digits, but I think this is correct. Whenever we find a parsed digit, we concatenate it to the front. And we say, and take the rest. I think that's correct. But let's write some tests for find digits just to be sure, right? I'm using a very lightweight test framework, as in none. But I'm writing some tests here. So let's write some tests for find digits. Find digits in the string 1 should be just the 1, right? That is working. Let's put in a 1 and a 3. That is working. Let's put some stuff in between. Also working. Let's start playing with 1 or 5. That appears to be working. Is it working? Yeah. What could be going wrong here? Let's try 5D6. Also working. Oh geez. Okay, let's start printing out the input. We could exhaustively test everything, but I think I'm just making a thinking error here. What could be wrong? What could be wrong? Do we have overlapping things? No. No, we don't. I'm stumped. If there is a bug in here, I would expect, knowing myself, I would expect it's in this substring index thing, but it appears to be going quite smoothly. Yeah, that appears to be going smoothly, right? 3, A, B, 2, 1, DD, 5. What should this be? 3, 2, 1, 6, right? I'm just trying random stuff now. I'm getting desperate. Okay, everything seems to be working, so I'm just going to start out printing our intermediate results for part 1 and start doing some hand verification by hand because I'm really not seeing it. I'm just going to print out our digits for every line, and I'm going to do that by injecting a print statement or two. So, I don't know what, I'm trying to do fancy stuff here, but we don't need to, we can just do print digits for the line maybe. So let's print out both digits and the line. And let's see what we have for our actual example, or our actual input, sorry. Okay. Let's go ahead and see what we have here. Five, 5, 2, 3, 1, 6, 5 GC. You know what? I'm also going to print out the end value so we can see everything that's going on here. So let's put our result into a let, and let's print it out and let's return it again. So let's print out the result as well. There we go. I'm really curious where this bug is located. I think it's the first time in how many years I've been doing this that I'm stumped on day 1. I must be getting old. This all looks very correct to me. Or we have a typo in one of the digits, or I'm doing something really silly. Three, 2. Why is there a 1 in here? Oh, there is a literal 1 in here. Okay. 1, 6, 2, 4. And it takes a 3 and a 4. Let's reread this thing again. Yeah, we're doing it correct, right? 76, 7, 6. What did we try? 5, 4, 5, 3, 3. And that was not correct. Four, 4. 1, 5, 2. Is it correct that when we have multiple digits to each other, we should take 84 should be 84. Wait. Why is this 14? Oh, because there's a 1 in there. Yeah, we tested the example, right? Example is 29, 83, 13, 24, 42, 14, 76. So that is actually correct. And in the input, I don't immediately see any problems. Dang it, dangany. Could we be overflowing integers? Absolutely not. Could we? 1,000 times, what, 100? Everything seems to be between 1 and 100. No, that is definitely below integer bounds. I am stumped. I am literally stumped. I'm just, for good measure, I'm just gonna input my guess again to make triple sure that I'm not going crazy here. No. Okay, if all else fails, just start going through the motions. I'm not seeing it, so I'm going to do the very painful job of exhaustively testing. I should be able to detect bugs like this by just looking at the code. That's like what's supposed to happen here, but it's not, so I'm just going to do some double bookkeeping and making sure that everything works as I expect. This is an interesting year. If all puzzles give me this much problems, I'm going to need to reserve a lot more time on Advent of Code this year. Because usually those first days are like nice warm-ups when you're learning a new language. Okay, so this works as expected. Yeah, let's do the same thing for my text-based digits. I'm sorry. So not the most interesting part of the day. But it's part of the job, right? When you're writing software, sometimes you hit stuff like this. You need to go through the hard part, the boring part, whatever you want to call it. The grit part. This is where you need grit as a software engineer to push through the not so interesting parts of life. So everything is parsing correctly. This is not amusing. It's going to be something very stupid, right? It cannot be otherwise. Where is my thinking error? Need to find the real first and last digit on each line. We are doing that. Adding these together. Yes, yes, yes. Let's go over the input. Let's do a... Now I'm going to go over the input with my intermediate results. That will give me more of an idea. Okay. What is going on here? It's only, what, 1,000 lines? That's a lot. I'm going to go and do some random inspections. What looks weird? Nothing stands out. Everything looks okay here. Five, 9, 2 looks correct. 7, 6 looks correct. Whoa. Could this be it? That's an instinker, as they say in Dutch. What should we be doing if we only have one digit in there? What should we be doing if we only have one digit in there? You need to find the real first and last digit. If there's only one, those are 2 times the same thing, yeah? A single 2-digit number. That's a very confusing problem statement. No. It's like, oh, you form a single 2-digit number. So, it's a shame that there's no real example here, right? Let's take a look at my input again. Is it really happening, or am I XHL1? XHL1. Yeah, it's in there. So, what should we try? N8. What should we try? Should we just... Yeah, let's just try it by not concatenating the 1 2 times and just taking it 1. I'm just gonna do it really dirty. So if we have our digits, if there's only 1 digit in there, that is the answer. And otherwise, we do whatever we're doing here. I think a lot of people are going to hit this roadblock. I think day 1 is going to be a bit more tricky for people because of this. If it's the problem. So let's see. We still have 281, and we have a different number. Let's see if our guess is indeed correct. Oh, this... That's a shame. Yeah, but now we don't even know which of the 2 approaches should work. I thought I cracked the case. Let's see whether or not this thing now does what I wanted to do first. Where's an example again? Let's start from the top. Last time we found it in the top, right? Where are you? Should have made this into a test case. Let's do this. Let's make it into a test case. Let's solve for XLH1, which was the thing that was failing, right? So yeah, now that is working, or now that is resolving to 1 and not 11. Was it not XLH1? It was something like that, right? on, give me something with 1 digit. Where are you? One XDM. Let's take that one, for example. Okay, let's take one XDM. Where are you? Why am I not seeing it in my output? Wait a second, why am I not seeing it in the output? Could it be my input parsing? Nah. XHL1 is there. XHL1 is there. Why is it not showing up? Wait. If it's a stupid parsing thing, I'm going to be pretty mad at myself. So it is in the input. What? Why is it not printing out? Why is there like an empty enter in here? That's not what's supposed to happen, right? Let's see what we're printing out here. Okay. So we have 938 lines of output. But if I open my input, I have 1,000 lines. I should have spotted this earlier. So let's get rid of the if-else thing, because that probably is not the bug. So this is irrelevant again, I hope. Our test case for that XLH1 can be 11, which is our assumption. But now let's take a look at what's happening. We have input. Input should be 1,000 lines. Which is correct. If we do input.listMap, we should have 1,000 lines. It makes sense. We have 1,000 lines. So why am I not seeing 1,000 print statements? Oh yeah, the if-else. Oh my god. Dearie me. We were not printing out in the if case. Situation normal. Everything is working as expected. Yeah, that was a silly goose chase. Okay, so that is also not a problem. I am really starting to scratch my head here. So we tried. We tried this. We tried the if-else thing. I'm just gonna try that again. So we know what we tried. There we go. Let's solve input again. So those are our two incorrect guesses. What else? What else? Let's try refreshing the page. Maybe there's some like update. No, there is not. No, I'm starting to get really stumped here. To make myself feel a lot better or worse, I'm gonna take a look at what my colleagues are doing. Let's take a look at our leaderboard. So people have solved part 2, right? No? Yeah, if you're on the leaderboard, you have... Can I not see stars? Maybe on the private ones. So this is our leaderboard. Someone solved part 2, but a lot of people, no, 3 other colleagues are struggling. So I might not be the only one not seeing the light here. I'm wondering whether or not this is deliberate. Part 2, I'm expecting not, so I'm expecting there to be something that's open to interpretation, something that is like, I'm thinking it's one way, but it was designed to be the other way. Stuff like things with only 1 digit. What else could happen? What if we don't have any digits? No, every line has a digit. Every line is a calibration value. No. There's not much we can do, huh? The example works. We can start looking at every line in our input by hand again, but that's the only avenues I have left in my head. Is my if in there? No, my if is not in there. Why is this test suddenly failing? Oh, it's not failing, it's just printing. Okay, yeah. It is printing, of course, so let's not worry about that. Let's print it out again for our input. And let's take a final look. I've been hammering at this problem for 50-something minutes. That is almost all the time I can give it today. So if I don't see it in the next 5 minutes, I'm going to have to admit defeat. Let's hope our eyes, our pattern matching brains see something here. Now, these are the most exotic things open for interpretation, but we tested everything possible here, right? We tested 4 in this case, and we tested 44 in this case. What else can we do with a 4QGF? I'm gonna take that in my head, that example. I'm gonna read the problem description one more time. Each line originally contained a specific calibration value that the elves now need to recover. On each line, calibration value can be found by combining the first digit and the last digit. In that order, perform a single 2-digit number. So we're always looking for 2 digit numbers by looking at first and last. And if it's the same, then let's assume we just take it twice. There is even an example in there. Trebuchet is a 7 and a 7, so it is definitely supposed to work like this. Yeah, it's in there. There is no ambiguity. That's even worse. One last look at my digits spelled out. Hmm. Seven, 8, 6, 7, 2, 1, 6. This looks super correct. We are always concatenating, not adding. Yeah. We're parsing from left to right. Could that be the problem? No, there's no overlap in digits, right? I mean, if we have like 2, but part of the 2 is... If we have 2 in text and part of that 2 is like part of the next digit, that could be a problem, but do we have a case like that? Nah, 9, nah. 7 and 2, oh no, starts with an S, ends with an N, starts with a T, ends with an E, F. I don't see any overlaps. Oh, but that could be a problem. Seven and 9 is an example. Say we... Actually, that could be the problem. Oh, if this is it, I'm going to be very happy. Let's parse 7 and 9. Seven and 9, where the N, so the last character and the first character match. What do we expect in this case? So what's the first digit? It should be a 7, right? And what's the last digit? It should be a 9. So I'm expecting a 7 and 9. And knowing how I wrote the code, this is not what we're gonna get. We're gonna get 7, 7, right? Okay, I'm calling my shot. I think this is the bug. Okay. Which is, it's doable to solve, but it's painful to solve. Okay, so assumption, this is the bug, overlapping patterns. And to find the last digit, we cannot just go from left to right. We actually need to go backwards, right? That's the easiest thing to do. Or, I think maybe a hack we can do is, instead of when we see 7, we eat up all characters of 7 and we continue, we can just eat up 1 and continue. I think might be a bit hacky, might be a bit dirty, but I think that's the least impact on our algorithm. So when we do rest here, let's not do rest, let's just skip 1 instead of the entire thing. Not very kosher, but it will, I think, solve this bug. So let's try that. Example still works. Let's run our tests. Let's run our tests. Why is it saying this value is not a function and cannot be applied? Okay, stuff is working. Let's run our tests. Yeah, now we are getting 7 and 9. Let's see. It is a different answer, so it could actually solve all our problems here. So we went on 2, 3, 4 maybe goose chases, but we actually got our start. T-Boat, if you found this yourself, my man, respect. Or you found it very quickly, I mean. I've been looking at this problem for an hour. Cool. This actually gave me the motivation boost to take a final look at our code and clean it up. Future me, or if you're looking at this and still stuck on part 2, I feel your pain. It's not unreasonable to expect this kind of behavior, but I would have liked this in one of the examples and not something to figure out on my own, especially for the first puzzle for day 1. I think maybe 7 and 9 is the only one where this happens. Is that in there? It's not in there, so yeah. This is a bump for a lot of people, I'm guessing. But let's stick to my experience. This was a bump for me. So there's 2 things I would like to do with this code that I'm not really happy with. One is we're doing a lookup here, but then we're doing the lookup here again. And the other one is this is a recursive function, but it's not tail recursive. So the longer this problem gets, the more stack frames this uses, and that's not really necessary. We could refactor this to be tail recursive, so it only uses a single stack frame and it's like as performant as a for loop, basically. And you do that by introducing an accumulator, so an accumulating variable that takes the result, and not just concatenating a list and doing a recursive call, because this means in order to build this list, you need to do the call and this has to stay on the stack, stuff like that. But if you just provide the list you're building as an argument, as an accumulator, it can use the same stack frame and keep on going. Very badly explained what tail recursion means, but let me show you how you refactor your code to it. So you actually need an accumulator, and if we're done, we just return the accumulator. Probably reverse it, because this is not my first rodeo. And when we do the recursive call, we just grow the accumulator. So we put parsed on the accumulator, and that's why we reverse in the end, because we're putting everything in front, but then we're building the list in reverse order. So when we're done, we reverse the list again. And here we just pipe in the accumulator. There we go. No, yes, no, yes. And to start, let's start with an empty string in the accumulator. So this is refactoring to tail recursion. Now, if you see, like in this recursive function, whenever we recursively call a function, it's the top level statement. So there is no list append around it anymore. And that's what it technically means to refactor to tail recursion. And now everything is broken off my test. That's true. You could wrap an outer function on it so you don't see the accumulator on your public API, but I'm not even gonna bother with that. I'm just gonna do find and replace and put an empty accumulator in there. And there we go. No? Yeah. So that should still work. I'm gonna pull out my debug statement, so my tests print out whether or not they're passing, and they're passing. We don't see any error messages. Cool. So that was the first thing I wanted to clean up, which is making this function tail recursive. I think there's even an attribute you can put on functions, tail call, yeah. If you use this, it's new from .NET 8, so F#8. If you use this, the compiler will actually tell you, hey, you think this function is tail recursive, but it's not. I don't think it works in FSX in script files. I think you need to have a solution that compiles and builds, but it's there. So if you're writing F#, and you worry about things like tail calls and tail recursion, now the compiler actually tells you whether or not your function is tail recursive if you want to. So that's a cool little addition to the language. Okay, so first thing we wanted to do was clean up tail recursion. Second thing I wanted to do was this lookup. Can we rework our code so we don't have to do the exists, find, starts with, so we don't have to do this thing twice. We could extract it out of the match. We could do, if we move this thing from the when to the right side of the pattern match, so to the evaluation part, then we could actually do it. So then it's not really very useful to do a pattern match with 3 cases. Then we only have 2 cases, like empty list, non-empty list, and we do everything on the right side. Actually, that sounds like a okay-ish thing to do. So if it's empty, return the accumulator. If it's non-empty, we can do stuff, right? We can do stuff. So what do? We look up a digit. Let's do a try find here. So let's try to look up a digit. If. So match on digits. Let's do a recursive digit. If we don't find anything, it's this thing. So we just continue on. And otherwise we found a digit. So yeah, we refactored this by not using a when a guard on our pattern matching, but putting this here, and now we can just reuse this. And we did try find instead of find. Find will always work or blow up, I think. Try find will return an option. So if we don't find anything, we have none. If we find something in the map for this key, we get a sum. And this should be a behavior safe refactoring, right? So I'm hoping to still see 281, and I'm hoping to still see my tests pass. Yeah, our tests pass. So this is safe refactoring. Let's do some minor cleanups. Cool. I think we are done for today. Let's take a final look at our code and wrap up. Because we hit the hour mark. Oh boy, day 1. So we were asked to find calibration values from an input document. Part 1 was pretty easy. We just needed to find every digit in there, find the first and last one. Part 2 had 2 interesting twists. First twist, this is also a digit, so the word 9 is digit 9, which made our finding digits a bit more tricky. We used a map with all the possible values mapping to their digits to find these things. And then we took about an hour to find a bug, which is if you need to find the last digit, there could be overlap between digits here, 7 and 9. You need to find the actual last one and not the first one. So, and we did that incorrectly. We did it, I called it a bit hacky to just not consume the entire thing we parsed, but I don't think it's really hacky. But an alternate approach could be for the last one, go from back to front. But this works, so I am happy. I already spent an hour on this. I'm going to call it a day. Whew. I hope it's all downhill from here. I hope the coming days will be easier. And otherwise, we are up for a wild ride, people. This was Additive Code in F# Day 1. I hope to see you tomorrow for more fun. Thanks and bye-bye.